So my name is Tauheed Khan Muhammad, and I am from Eastern Michigan University. The topic which I'm going to today is enhancing time series anomaly detection, a hybrid model approach. This study would have been carried by my student Paula Dai, and there's another faculty member. His name is Pedro Pinto from Instituto Politécnico de Viana de Castelo from Portugal. And I am assistant professor at Eastern Michigan University. My talk will be divided into these related topics. One is introduction. Then we talk about the related work we have done. Then we talk about anomaly detection, results, and then conclusion. First of all, I'll introduce what is time series data and what do you mean by that. So as we can see that these days, a lot of companies, when they run their graphs, what they do is they will be having some sort of spikes in their graph in their daily usage or in daily sales. Perhaps they can find that something is fluctuating. That gives an idea that that's an anomaly. Something is wrong, either with the infrastructure or there's something is wrong with the information provided. So in that scenario, time series data comes into the picture. It also referred as timestamp data, and it's a sequence of data points indexed in time order. In this paper, we explore types of anomalies and propose efficient detection methods which can be used. Anomalies are the pattern that deviate from usual expected behavior. These can come from system failures or unexpected activity. Our research explored the vulnerabilities and commonly used anomaly detection algorithms, which are Z-score and static threshold approach. So this is we talk about over here, right? And we can talk about the second thing is we have an anomaly is something that deviated from what is standard, normal, or expected. So we are talking about over here is a timestamp, which we can see is the fluctuating and spikes over here, right? So that's basically we can talk about over here. Moving on, related work. So we can talk about over here, the related work we can discuss is Microsoft algorithm pipeline for continuous time series monitoring and anomaly detection. And we have used the model called SARIMA model in the network bandwidth anomaly. So these are the few of the libraries that we have used while working on this particular research topic. And then we also detected some other, we also explored some papers which they talk about the detection of anomalies such as Greykite and Prophet Python library, right? Now, the third part is comparative analysis of forecasting methods using SARIMA, method vector machines, support vector machines, and artificial neural networks. So we are talking about over here these related work which we have explored certain papers, certain articles, and we find out that these are basically some algorithm from Microsoft and other different researchers who carry out this research, where you have used these libraries to explore and finding whether we can find anomalies in particular data. It could be any kind of data that perhaps we have also read about an article which is called Anomaly Detection, a survey, which is done by researchers from India. And they have found out a comprehensive survey of various techniques for anomaly detection across multiple domains. Those authors, they have also highlighted the importance of anomaly detection as a critical task for detecting outliers, identifying suspicious activities, and preventing fraud in various domains, including finance, healthcare, and cybersecurity. Our paper also talk about defining the problem of anomaly detection and discussing the significance in various applications. The author then provide also to talk about the taxonomy of various anomaly detection techniques, such as statistical method, machine learning approaches, and data mining techniques. Right. Moving on. So our anomaly detection technique, they talk about the application of LSTM neural network, Z-score, statistics, Prophet Python library, Greykite Python library for detection anomalies in time series data. The example which we pick, the current example is, for example, Amazon has a sale of, let's say, $2 million every day. And some night they find a spike and say that, yeah, the sale is today is just, let's say, $500,000. So there's something wrong with the data. So that means there's a huge loss. Why there's a spike and what we need to do for that. So that's how we need to find out what we could do in that situation. So this kind of approach will help us to find and figure out those problems. And from there, we can detect and try to resolve the issues and make sure how we can resolve those spikes. Now, so if we talk about two techniques, one is we talk about, first of all, we have discussed Microsoft system overview. And over there, what we discuss over here in that one, Microsoft provides its own solution that we can do with that. Second approach we have used is called LSTM neural network, which is long short-term memory. And this is one of the common deep learning models for anomaly detection. LSTM, as I mentioned, it stands for long short-term memory, which is a type of recurrent neural network and RNN architecture. It is designed to address the problem of vanishing gradients in traditional recurrent neural network. The second category is called Z-score, which talk about statistics. The Z-score equation can also be used to detect anomalies using the average and standard deviation of a data point. It's a very well-known technique. It talks about a static threshold needs to be set to help to satisfy and classify a data point as an anomaly. Z-score is able to detect anomalies by identifying data points that deviate significantly from the mean of the standard distribution. It means the number of standard deviation a data point is from the mean. That means it's an efficient way to find the anomalies. For example, somebody is way ahead from the mean or somebody is way ahead from the standard deviation. Right. So this is the second technique. The third technique talks about Prophet. That's Python. That's a Python library that's from Facebook. Facebook researchers, they have done, they've created this library the way we have other framework from Facebook. Similarly, this is TensorFlow, and then we have other libraries from machine learning libraries. So TensorFlow is from Google. Prophet is one of the libraries that's been used created by Python for creating a Python micro framework library for financial markets. These days, there are a lot of companies in the market who are very much concerned about their data. They talk about the businesses and things like that. The Prophet library is able to forecast data, which this feature can also be used to detect anomalies by calculating the delta change in the actual data and forecast the data, that how much business I'm going to do and how much business we have in the past, what's going to be in the future. That's all been done by using this Python-based library. However, this would require a fixed value, which could be used to classify the calculated data on the basis of anomaly or not. For example, we say that I am supposed to have a $50 sale today. Let's say, for example, a hypothetical example, and I have a sale of, let's say, 5,000. That's an anomaly. That's something different. Or the other way around. We are supposed to have a sale of, we are expecting a sale of $5,000 today, but for some reason we just got $50. So that's basically a big spike. This is again another way of classifying the third way of classifying those anomalies by performing this Prophet Python library. It's a simpler way used, and it will provide certain variables, and based on that, it forecasts the data and classify any value above this anomaly. Then we have the fourth category, which is called Greykite, which is a Python-based library. And Greykite is a Python library for the time series forecasting and analysis developed by LinkedIn. It provides a suite of powerful algorithms and technical techniques that could be used to analyze and predict time series data in a variety of industries, from finance or retail to healthcare. So these are the four different kinds of anomaly detection techniques I mentioned. I can repeat again. One of them is LSTM, which is called long short-term memory. Second one is called Z-score. third one is called Prophet, and the fourth one is called Greykite, which is from Python. Right. Then we also use static and dynamic threshold methods and the forecasting method for anomaly detection. Right. Now, coming to our experiment, what we have done and what the result we have received. So in this diagram, if you can see over here, there are diagram which talks about forecast versus actual. The diagram which you are seeing in the pink, it talk about data after z-score algorithm was applied. And the other one which we talk about over here, which is the bottom one, which is in the blue background, that's talk about the data before anomaly. This is basically, this is again, data before anomaly filtering. So a static threshold represents a hard limit that a metric should not violate. Then we have a dynamic threshold, represent the bound and expected data range for a particular data point. And then we talk about forecasting. Forecasting is the prediction that's being used by algorithm. So we define our own standards. It varies from business to business what my anomaly is to be. I want to see my business $5,000, and if I say $50, that's basically an anomaly for me. That's my definition. It could be normal for others, but we don't have to be follow that way. So forecasting prediction made by studying historical data points and past patterns, right? So this is the way that through which we can perform those experiments by applying machine learning algorithm on data. The data set which we have used that's been available on internet, we can download New York taxi data, and we also use some information data that's been available from Amazon, right? Now, let's talk about the method. So anomaly aggregation refers to the process of combining multiple signals or data streams to detect and analyze the anomalies that may be apparent when looking at individual data points. Some potential approaches to anomaly detection and aggregation includes statistical aggregation, which involves using statistical methods such as mean, median, mode, standard deviation, or correlation to aggregate multiple data streams and identify anomalies. Could be an example of if you have to monitor network traffic from multiple sources. You could aggregate the traffic volume and look for spikes or dips that are significantly significant. Another example is machine learning based aggregation, which involve training in machine learning model to identify anomalies in individual data streams, and then using an ensemble method to combine the result from multiple models. So these are basically some of the methods through which we could use. Some of them is called, so the method which we can talk about over here is static dynamic threshold method. Second one would be called forecasting method. And we have defined our own algorithm. We have provided a pseudocode in the paper that could be used for detecting those anomalies. Now let's talk about the results. So when we talk about a particular thing that we talk about on a normal behavior, if we find a spike, that anomaly could be detected. If you've seen the screen that we find a spike, a plateau, which talks about that, how we can figure it out that this is an anomaly. Where my cursor is right now, this is considered to be an anomaly. So when examining the advantages of using the forecast methods versus the threshold-based anomaly detection, it becomes more clear that the forecast method outperforms the threshold approach in terms of accuracy and effectiveness. So I feel like the second approach, which is a threshold, it's been performing. The forecast method has been working better. The threshold methods. It's suitable for capturing the spikes in data. The threshold methods proves inadequate when it comes to detecting certain types of anomalies. To illustrate my point, we can consider an anomaly that occurred on April 12th, as shown in the figure. That we talk about that's in the data that we talk about is pretty small, and perhaps you cannot see that there are some dates at the bottom. So we can see a certain spike over there that could be detected by using those forecast methods, and we find out based on analysis that these are considered to be one of the good ones. Right. After training these two models, figure 2 shows how well the model would be able to forecast the next data points. Figure 3 shows the comparison between the data point and a forecast. And looking at this, the data, it clearly shows where the anomalies are located. Figure 4 shows where the anomaly data points are located without the forecast data point, which are in figure 5. So these are some of the ways through which we can find out those anomalies. We signal severity value above 52 as an anomaly. Conclusion. The importance of benchmarking different approaches on real-world databases to determine the most effective method and to bring about effective and dependable anomaly detection techniques. Now, it is important to note that detection of time series anomalies in the end may not be easy, considering its many type of anomalies. For efficient capturing and detection of different type anomalies type, specific modeling strategies are needed. Relying on only anomaly detection model will be too risky because every model possesses certain unique characteristics, unique properties that make it prone to various attacks. In this attempt to address these limitations, researchers and practitioners have identified the merits of integrating the various models, such as approach would utilize different features of one method to cover another's weakness, while benefiting from the strong side and to develop a strong base with more accurate, secure results. Nevertheless, one should emphasize that the topic is relatively fresh and not people are working on it. This is quite new for the companies and they want to protect their business. That's the important thing. That's the key selling point for this thing. So there are still many questions to be raised here, but we find out that some of the algorithms, some of them have their own limitation, but we can overcome by combining them with others. Right. And that's all from my side.